Dear students, atomic radius and ionic radius also, both are very important concept for objective point of view. So here, atomic size, how can we define the atomic size or atomic radius? Now here, that is the simple definition. There is the atom and nucleus. The distance in between nucleus and valence shell electron. So this distance is known as atomic radius. If it is ion, that is called as ionic radius. Both are in same positive ion or negative ion. Then here same definition, that is distance between the nucleus and valence shell or electron, right? That distance is known as atomic ionic radius. Ionic radius. This is atom. Atomic radius, right? So this is the simple definition. Now in objective point of view, dear students, in a group from top to bottom, atomic size increases because the reason is from top to bottom, new cells are being added from one atom to another atom. For example, in first year group, hydrogen, lithium, sodium, potassium, rubidium, cesium, francium atoms are there. So hydrogen has only one shell, and lithium 2, sodium 3, potassium 4, rubidium 5, cesium 6, francium 7. 7 orbits are present in francium. That's why with the increase of number of orbits, the size of atom also increases. Now in a group from top to bottom, atomic size increases. Right? Now next, in a period, you have to observe in period also. Right? In a period from left to right, atomic size decreases. Atomic size decreases because the reason. So you have to observe the second period. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. Neon is the inert gas. We cannot give the information here because it doesn't form any bond with other. That's why other element. That's why we cannot determine the radius of inert gases by using this concept, because their radius is measured by using only van der Waals radius. That's why they are bigger than 7th A group elements. So inert gases belong to 8th A group. Then they are bigger than 7th A group elements because their radius is measured by using van der Waals radius. That's why they are bigger. Right? Now in these cases, so lithium has 1s2 2s1 configuration, beryllium 2s2, here boron 2s2 2p1, carbon 2p2, like that, 1s2 2s2 2p2, and nitrogen 1s2 2s2 2p3, and oxygen 2p4, fluorine 2p5. Now here lost electron or differentiating electron in all these elements enter into same orbit, that is second orbit. Same orbit, that is second orbit. That's why the nuclear attraction increases over the valence shell. With the increase of atomic number of protons increases and number of electrons also increases. Then the nuclear attraction increases over the valence shell. Then that's why so size decreases from left to right, because the important reason is the differentiating electron or lost electron enters into same orbit. That's why all are having two orbits only. Then number of protons increases from lithium to fluorine. That's why if number of protons increases means nuclear attraction or nuclear force of attraction increases over the valence shell. That's why valence shell pulls towards the nucleus, then size decreases. Right? Now in a period from left to right, atomic size decreases. So by using this concept, we have to identify the correct option in objective point of view. Right? Now dear students, another important one is size of cation and anion. So how can we identify the size of cation and anion? Cation is positively charged ion. When they lose electron, that becomes positive ion. That is known as cation. If positive charge increases, means it loses number of electrons, then size of ion decreases. For example, sodium, magnesium, aluminum you have to take. Sodium atomic number 11, magnesium atomic number 12, aluminum atomic number 13. When it loses one electron, then it has only 10 electrons and positive charge. That means here it has only 10 electrons and 11 protons. When we observe the magnesium, it is in +2 state, 2+. It loses 2 electrons. Then it has only 10 electrons and 12 protons. Now in the case of aluminium, 13 atomic number, it has 13 electrons and 13 protons. When it is in +3 oxidation state or 3+ oxidation state, it loses 3 electrons. Then it has only 10 electrons and 13 protons. Now you have to absorb these 3 ions as the positive charge increases, +1, +2, +3. As positive charge increases, the size of ion decreases because electrons are same but number of protons increases. Number of protons increases means nuclear charge or force of nuclear attraction increases. Then valence shell comes closer to the nucleus. Valence shell comes closer to the nucleus. Then size of ion decreases. Then size of ion decreases. Size of ion decreases. That's why as the positive charge increases, as the positive charge increases, size of ion decreases. Right? If it has more positive charge, that is smaller in size. In this way, you have to identify the size of cation. Next, size of anion. Size of anion. You have to identify the size of anion. Anion means negatively charged ion. Negative side. When it gain electron, that becomes an ion. Right? Now, as the negative charge increases, size of anion increases. For example, nitrogen, oxygen, fluorine. When we absorb these three, nitrogen gains 3 electrons, it becomes nitride ion, 3 minus ion. Oxygen, it gains 2 electrons to get nearest inert gas configuration because it's atomic number 8, nitrogen 7, 8, 9. Right? Now it gains only 1 electron, then it attains nearest inert gas, that is neon configuration. Right? So all these are having 10 electrons, 10 electrons, 10 electrons. Right? 7 plus 3, 8 plus 2, 9 plus 1, 10 electron. But these are having only less number of protons. Nitrogen has only 7 protons, oxygen 8 protons, fluorine 9 protons. Fluoride ion has 9 protons, oxide ion has 8 protons, nitride ion has 7 protons only. Now in this case we have to observe, as the negative charge increases, number of protons decreases. That's why with the increase of negative charge, size of ion increases. Right? As the negative charge increases, size of anion increases. You must and should remember this now. To identify correct option, as the positive charge increases, size of ion decreases. As the negative charge increases, size of ion increases. By using this concept, you have to identify the correct option when this type of objective bit is given. Right? So this is very, very important concept. This is the given example. You have to observe the correct order of the atomic radii of carbon, cesium, aluminium and sulfur is. Now in this you have to observe first. So these given elements belong to which group? First you have to identify that. Here first one, cesium is the first A group element. That is the last but one, that is bigger in size. Next one, aluminium. Aluminium is the third A group. Right. Next, carbon. Carbon is the fourth A group. Right. Next, sulfur is the sixth A group. Right. Now first A group cesium, third A group aluminium, fourth A group carbon and sixth A group is sulfur. When we identify the correct option, first you have to observe the place of these elements in the periodic table. So in first A group, cesium is the last but one. It is bigger in size. Right? Next, in this aluminium, carbon, sulfur. Carbon belongs to 4th A group. 4th A group, and it is a second period. Now you have to observe this. Cesium is the 6th period element. So aluminium is 3rd period element. Carbon 2nd period, and sulfur also 3rd period element. Right? 2nd, 3rd, 6th. Now you have to observe first aluminium and sulfur. Aluminium, sulfur both belong to 3rd period. Right? Now you have to observe first aluminium belongs to 3rd A group and sulfur belongs to 6th A group. So in a period left to right size decreases. That means aluminium bigger than sulfur. Aluminium bigger than sulfur. Next, carbon. Carbon belongs to 2nd period, then that is smaller in size. Right? 2nd, 3rd, 6th. Down the group, size increases. Then the correct order is bigger is cesium, smaller is carbon, because carbon belongs to 2nd period, and both sulfur and aluminum belongs to 3rd, cesium 6th. So here the correct option is carbon less than, sulfur less than, aluminum less than cesium. So that is the correct way of analysis. Right? Now in next, I will give one next model. So that is, so here you see this one is also very important. This was also given in previous examination. Now the order of increasing size of atomic radii among the following elements: oxygen, sulfur, selenium, arsenic. So oxygen, sulfur, selenium both belong to 6th A group. In a group from top to bottom, atomic size increases. Next one, arsenic. Arsenic belongs to 5th A group, that is nitrogen family element. Nitrogen family element. Right? So here nitrogen, phosphorus, arsenic, antimony, bismuth. Right? Now here. So oxygen smaller than, then oxygen less than, because that is the first one. Next sulfur less than, next selenium less than. Now in between selenium and arsenic, first 5th A group, arsenic, 6th A group, selenium. Right? Selenium. Then in a period from left to right, size decreases. That means arsenic bigger than selenium. Right? This is arsenic. Right? Now this is the correct order. Now in this, correct option is oxygen less than, sulfur less than, selenium, because they belong to same group. Arsenic 5th group. That's why it is bigger than selenium. This is the correct option. Like that we have to analyze. Now next, when we use ions, here you see this one. Which of the following has largest ionic radius? Lithium, peroxide ion, boron ion, fluoride ion. As the negative charge increases, size also increases. As the positive charge increases, size decreases. So these two are bigger in size. But oxygen has 2 atoms, then it is bigger in radius and more negative charge. That's why its radius is more. That's why this is the correct option. Like that, we have to analyze the correct options. Right? So I will give one more example. One more example in that. This is also very, very important. Best example. Right? Now here, the correct order of increasing ionic radii. Sodium, magnesium, nitride ion, oxide ion, fluoride ion. So as the negative charge increases, size increases. So nitrogen bigger in size. Then oxygen. Then fluorine. In these two, as the positive charge increases, size decreases. Magnesium 2 plus ion is smaller than sodium ion. That's why. So here the order of increasing, first small atom, that is magnesium, less than sodium, less than fluorine, less than oxygen, less than nitrogen. So this is the correct option. So you have to remember here, so size of ion depends on charge. As the positive charge increases, size decreases. As the negative charge increases, size increases. Based on that, you have to identify the correct option. Dear students, if you like this video, please subscribe for more videos like this. Thank you.